Hello everyone, welcome to this video. In this video, we are given that H is a subgroup of the group G, correct? We have to prove that this set, which is constructed by multiplying this subgroup H with the center of this group ZG, and the elements are obtained in such a manner that they are in this form HZ, where this H is taken from the subgroup capital H and Z has been taken from the center of the group G. Now remember the definition of center of group G. It contains all the elements X from the group G such that X commutes with all other elements for all G belongs to G, right? This element X commutes with all other elements of the group, correct? This is our center of the group. Now we have to prove that Hz of G, which is given by Hz, where this H is taken from the subgroup H, whereas small z has been taken from the center of G. We have to prove this is a subgroup of G, correct? So how we can prove this? In order to prove this to be a subgroup, we first of all show that the identity element is present within here. I say HZG is non-empty. Why? Because as E belongs to HZG. Why? Because E, the identity element of G, could be written as E into E, right? This belongs to HZG. Why? Because as E belongs to H, because H is given to be a subgroup of G, so it definitely contained the identity element. And moreover, E also belongs to the center of G. Why? Because it commutes with all other members. Therefore, their multiplication, which is E, is present definitely in this subset, right? So this subset is non-empty. Now next, what we do, we take two elements from this set. So we consider, let H1Z1 and H2Z2 is contained in HZG. So what does it mean? It means that H1 and H2 has been taken from H, and Z1 and Z2 has been taken from the center of the group G, correct? So we have this result. So now next what we do, we consider the first element H1Z1 and the inverse of second element H2Z2 inverse, right? If this element is also present in HZG, then by one step subgroup test we have proved that HZG would be is a subgroup of G. So let's consider this and see if this is also present in HZG or not, correct? So for this you can write it to be like this: H1Z1, Z2 inverse and H2 inverse. Why? Because we can make use of socks and shoe property, correct? In which we reverse the order if we have inverse. Now this could be written as H1Z1. We can commute both of them. Why? Because I wanted to make this come to this place, right? So for doing so, I can write it like this: H2 inverse, Z2 inverse. Why? Because H2 is a member of H, so it would mean H2 inverse is a member of H. And moreover, if Z2 is a member of the center of the group, so that means because this is a subgroup, Z2 inverse is a member of ZG center. Why? Because as Z of G is a subgroup of G, correct? This thing we already know. So next we can write this to be like this: H1 Z1 H2 inverse Z2 inverse. So that means we have just make use of associative property. Now again you can make use of this property to write it like this: Z1 Z2 inverse. Here Z1 H2 inverse is equal to H2 inverse Z1, as Z1 belongs to the center and all the elements of the center commutes with all the other elements of G, and definitely H2 inverse is present in H, so it will definitely be present in G, correct? So this is what H1 H2 inverse, Z1 Z2 inverse. Now you can make use of associative property to write the brackets like this. Now this whole element would be member of HZG. Why? Because as H1 H2 inverse belongs to H, correct, and Z1 Z2 inverse belongs to ZG, as both H and the center of the group ZG are subgroups of the given group G, correct, subgroups of G. So from here we have proved that this element is also present in HZG. Hence we can conclude by one step subgroup test HZG is a subgroup of G, and this is what we wanted to prove here in this particular video. So I hope you understood this question well. That is it for this video. Thank you for watching.